Good morning, everyone. Can you hear? Okay, so let us start our new topic, planes. In the last class, we were discussing about equation of lines in vector form and in Cartesian form. And in that, the first case is equation of a line. To write the equation of a line through a given point and parallel to a given vector, and the second one is equation of a line passing through two given points. So here we have to find the equation of planes. So in this topic we are going to learn about equation of planes. So write as the subheading equation of planes. In this also we have to write the vector form and the Cartesian form, and three different cases we have to learn here. In case of lines, two different cases. Here three different cases are there. Of that, the first one is equation of a plane in normal form. Equation of a plane in normal form. This is the first case. This means, see, in this XYZ plane, a plane is given to you. A plane is given here. Then the first case is, consider any point P on this plane. This is a plane in space, and here consider any point in this plane and take that as P. The position vector of this point P is taken as vector R. Position vector is taken as vector R. And here, to write the equation of the plane in normal form, we require the perpendicular distance from the origin to the plane. We have to get the perpendicular distance of this plane from the origin. We have to imagine this. Consider a plane in space. Consider the origin. From the origin, you have to take the perpendicular distance to this and let that be equal to D. The perpendicular distance to this plane be equal to D. And the normal vector, that is the vector which is perpendicular to this plane from the origin, that be N, vector N. Okay, so first one, we have to get the perpendicular distance from the origin to the plane and also the vector which is perpendicular to the plane from the origin. Let that be N bar. Okay, this vector N be a perpendicular vector from the origin to the plane and D be the distance from the origin to the plane. Then the equation of the plane is vector R dot N cap is equal to D. This is the equation of the plane in normal form. N cap means it is the unit normal vector, where n cap is the unit normal vector from the origin to the plane, and D is the perpendicular distance. D is the perpendicular distance from the origin to the plane. Origin to the plane. So this is the vector form of the equation of a plane with the unit normal vector as n cap and the perpendicular distance as D. Since this is a unit vector, you know that the magnitude of n cap is 1. So the direction cosines are, we can write this n cap can be written as Li plus Mj plus Nk, because this is a unit vector. The scalar components will be the direction cosines. And R is an arbitrary point on this position vector of an arbitrary point P on this plane, whose coordinates are taken as x, y, z. So we can write vector R as xi plus yj plus zk. So this can be written as, see, R dot n, that is xi plus yj plus zk dot Li plus Mj plus Nk is equal to D. This equation can be written as R dot n cap is equal to D, and you know how to find the dot product of two vectors. We can write this as Lx plus My plus Nz is equal to D. This is the Cartesian form of a plane. Cartesian equation of a plane. Is it clear? Okay, so remember these two. This is the vector equation of a plane when the unit normal vector and the distance from the origin to the plane is given, R dot n cap is equal to D. When you write this in Cartesian form, it becomes Lx plus My plus Nz is equal to D. Here, see, since these are the direction cosines, L square plus M square plus N square is equal to 1. So you can identify whether these are the direction cosines or the direction ratios by checking L square plus M square plus N square. So if this is equal to 1, then the coefficients are the direction cosines, otherwise they are the direction ratios. Let us do some questions from this. First one. In each of the following cases, Determine the direction cosines of the normal to the plane and the distance from the origin. And the distance from the origin. In each of the following cases, determine the direction cosines of the normal to the plane and the distance from the origin. So the first one is Z is equal to 2. This is the equation of the plane given to you. So can you say whether this is vector form or Cartesian form? So you have to identify this. The first one will be of the form r dot n cap is equal to d. The second one lx plus my plus nz is equal to d. So this is the vector form and this is the Cartesian form. So in which is this one given here, z is equal to 2. Compare with this. It is the Cartesian form. See, now we can write this as 0x plus 0y plus 1z is equal to 2. Okay, that is of the form. Either this, you can consider this as ax plus by plus cz is equal to d, or you can consider this as lx plus my plus nz is equal to d as a square plus b square plus c square, that is 0 square plus 0 square plus 1 square. This gives 1. Else, so when you find this is equal to 1, the magnitude of the vector is 1. That means it is a unit vector. N cap is given to us. So the direction cosines here are, therefore the direction cosines are zero, 0 and 1. And this is equal to lx plus my plus nz is equal to d. When these coefficients are l, m and n, then this is the distance from the origin. So distance from the origin is is 2. This is equal to the distance from the origin. You can check the sum of squares of this coefficients of x, y and z. If it is equal to 1, we can say that they are the direction cosines. If they are the direction cosines, this gives n cap. If it is n cap, this right side is the distance from the origin. Is it clear? Okay, then let us move to the next one. X plus y plus z is equal to 1. X plus y plus z is equal to 1. Again, this is given in Cartesian form. You can consider the coefficients of x, y and z. Let us take the square of this. Coefficient of x is 1, 1 square plus coefficient of y is 1, again 1 square plus coefficient of z is 1. So it is equal to 3. That means this coefficients of x, y and z are not the direction cosines because the magnitude here is 3. See, now when you write this in vector form, you can write this as xi plus yj plus zk dot. See here x, y, z, xi plus yj plus zk, and the coefficients here 1i plus 1j plus 1k. This is equal to 1. Since this is not a unit vector, we can write this as r dot vector n is equal to d. If you have to get these as the direction cosines, this must be n cap. That must be a unit vector. So how can you change this to a unit vector? You can write this as xi plus yj plus zk dot. See, the magnitude here is root 3. Okay, magnitude of this vector is root 3. So we can divide both the sides by root 3. So it is I plus j plus k divided by root 3, which is equal to 1 by root 3. Okay, xi plus yj plus zk dot I plus j plus k divided by root 3 is equal to 1 by root 3. Now the coefficients 1 by root 3, 1 by root 3, 1 by root 3, which gives a unit vector. So this is of the form r dot n cap is equal to d. If this is n cap, then the coefficients are the direction cosines. So the direction cosines are 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 3 and 1 by root 3, and the distance from the origin is 1 by root 3. This is the distance from the origin. Is it clear now? Okay. See, when you get the question, you have to check whether this is vector n or n cap. If it is vector n, you have to find the corresponding n cap, that is the unit vector, by dividing the vector with its magnitude. When you divide this side, the right side also you have to divide. With the magnitude. Then this will be of the form r dot n cap is equal to d, and the coefficients of n cap gives the direction cosines and the right side gives the perpendicular distance from the origin. Okay, try another one. 2x plus 3y minus z is equal to 5. 2x plus 3y minus z is equal to 5. This is the equation of a plane. How can you write this in vector form? Please give your answer in vector form. Here this is written as xi plus yj plus zk dot 1i plus 1j plus k equal to 1. How can you write this in vector form? How can you write this in vector form? See, here it is x, y and z in vector form xi plus yj plus zk dot. Here the coefficients 2, 3, minus 1. So it is 2i plus 3j minus k is equal to 5. This is the vector form here. R dot. Now you have to identify whether this is a vector n or n cap. To identify it, you have to find the magnitude. What about the magnitude of this vector? What is the magnitude of this vector? It is root 14. Okay, so this is root 14, that means not equal to 1. So we can write this as vector n is equal to d. This is not n cap, it is vector n. So we have to change this to n cap by dividing with the modulus. So this gives xi plus yj plus zk dot. You can write this as 2i plus 3j minus k divided by root 14. Root 14, which is the modulus of this vector. Then this becomes a unit vector. So this is equal to 5 by 14. 5 by root 14. Okay, dividing both sides by modulus of this vector, you will get this as r dot n cap is equal to d. Therefore, the direction cosines are 2 by root 14. Here the first one 2 by root 14, then 3 by root 14 and minus 1 by root 14. 3 by root 14 and minus 1 by root 14 are the direction cosines, and the distance from the origin is 5 divided by root 14. Distance from the origin is 5 divided by root 14. Okay, one more question. 5y plus 8 is equal to 0. 5y plus 8 is equal to 0. How can you write this in vector form? Here only the coefficient of y is there. We can write this as 5y is equal to minus 8. Okay, 5y plus 8 is equal to 0, which can be written as 5y 0x plus 5y plus 0z is equal to minus 8. And this in vector form can be written as xi plus, see xy and z here, xi plus yj plus zk dot 0i plus 5j plus 0 k. This is equal to minus 8. What about this vector? Vector n or n cap? It is vector n, so you have to convert this into a unit normal vector. For that, let us write this as xi plus yj plus zk dot. What's the magnitude of this vector? It is 5, so we are dividing this by 5, which is equal to minus 8 by 5. So what are the direction cosines? Okay, it is 0 by 5, 5 by 5, 0 by 5. That is 0, 1 and 0 are the direction cosines, and the distance from the origin is distance from the origin is minus 8 by 5. Minus 8 by 5. Is this first type of question clear to you? Okay, so let us do the next one. Second question from this is, find the vector equation of a plane which is at a distance of 7 units from the origin. 7 units from the origin and normal to the vector three I plus 5j minus 6k. 3I plus 5j minus 6k. The plane is normal to the vector means perpendicular to this vector. So you have to check the magnitude of this and to identify whether this is vector n or n cap. So what about this? Is this only a normal vector or normal unit vector? Normal vector is denoted by vector n and normal unit vector is denoted by n cap. What can you say about this? Only a normal vector or is it a normal unit vector? It is vector n. It is only a normal vector because the magnitude is not equal to 1. So we have to write the corresponding. First let us write this as 3i plus 5j minus 6k. Let us find the normal unit vector to this. What about the magnitude of this vector? It is root 70. Okay. Root 70. So to find the unit normal vector, we have to divide this vector by its magnitude, that is root of 70. Now we can write the equation. Equation of the plane is r dot n cap is equal to d and 7 is the distance from the origin. Distance from the origin. So we can write this as vector r is r dot n cap is 3i plus 5j minus 6k divided by root 70. This is n cap. So r dot n cap is equal to d, 7. This is the vector equation. Is it clear? Okay, now the next one is find the vector equation of the plane. Find the vector equation of the plane which is at a distance of which is at a distance of 6 by root 29, 6 by root 29 from the origin, and its normal vector from the origin is is 2i minus 3j plus 4k. Also find the Cartesian form. Also find the Cartesian form. Also find the Cartesian form. So what about this vector? It is vector n. This is equal to, since the magnitude is not equal to 1, it is vector n. 2i minus 3j plus 4k is vector n. Find out n cap from this. It is 2i minus 3j plus 4k divided by its modulus. Divided by root 29. So here 2 square 4, 3 square 9, 4 square 16, 16 plus 9 25 plus 4 29 it is. So n cap is 29. So we can write the vector equation as is r dot n cap is 2i minus 3j plus 4k divided by root 29. This is equal to, distance from the origin is given as 6 by root 29. 6 by root 29. So this is the vector equation. How can you write the Cartesian equation? Cartesian equation, to write the Cartesian equation, we are considering this vector r as xi plus yj plus zk. When taking the dot product, I, j and k replaced with x, y and z. So you can write it as 2x minus 3j plus 4k. So it is 4k. 2x minus 3y. 2x minus 3y plus 4z divided by root 29 is equal to 6 by root 29. So from both sides this root 29 get cancelled and the answer is 2x minus 3y plus 4z is equal to 6. This is the Cartesian form. Is this clear? Okay, this I, j and k to be replaced with x, y and z. So this becomes, because we are taking the dot product with xi plus yj plus zk. And then since root 29 is a common denominator here, we can cancel these two. It becomes 2x minus 3y plus 4z is equal to 6. So one more question. Find the Cartesian equation of the following planes. Find the Cartesian equation of the following planes. First one is r dot I plus j minus k is equal to 2. R dot I plus j minus k is equal to 2. So how can you write the Cartesian form here? R is xi plus yj plus zk. So here the coefficients 1, 1, minus 1. So you can write this as 1 into x plus 1 into y minus 1 into z, which is equal to 2. This is the Cartesian form. X plus y minus z equals 2. Okay, is this the distance from the origin? Is this 2 the distance from the origin? How can you check it? Check whether this is a unit vector. This is not a unit vector, as the coefficients are 1, 1, minus 1. Taking the sum of squares, 1 plus 1 plus 1, it becomes 3. So this is not the distance from the origin. If you have to get the distance from the origin, you have to divide both sides by root 3. Okay, another one. R dot 2i plus 3j minus 4k is equal to 1. R dot 2i plus 3j minus 4k is equal to 1. Give the Cartesian form now. Okay, it is 2x plus 3y minus 4k is equal to 1. Now what is the distance from the origin? Here the distance from the origin is 2 by root 3. What is the distance from the origin here? It is 1 by root 29. Okay, distance from the origin is 1 by root 29 in this case. Try one more question. R dot s minus 2t into I plus 3 minus tj plus 2s plus tk, which is equal to 15. It's equal to 15. What is the Cartesian form here? S minus 2t x plus 3 minus t y plus 2s plus t z equals 15. This is the Cartesian form. So another one, find the coordinates of the foot of the perpendicular. Find the coordinates of the foot of the perpendicular drawn from the origin. Find the coordinates of the foot of the perpendicular drawn from the origin. First one, 2x plus 3y plus 4z minus 12 equal to 0. See, first you have to write this in vector form, that is r dot n cap is equal to d. R dot n cap is equal to d. So you have to write this as, this can be written as xi plus yj plus zk dot 2i plus 3j plus 4k. 2i plus 3j plus 4k, which is equal to, this 12 is transposed to right side. So this is equal to 12. See, here this is not a unit normal vector. So we have to change this to n cap. For that, let us divide. We can write this as r dot. This is vector r dot n cap. To find n cap, 2i plus 3j plus 4k divided by magnitude is root of 4 plus 9 plus 16. It is root 29. This is equal to 12 divided by root 29. Okay, when this is given in Cartesian form, express this in vector form as r dot n cap is equal to d. And now we can write L, M and N from this, also D from this one. Therefore, the foot of the perpendicular from the origin is, see, this is what you have to do. Foot of the perpendicular means here a plane, you are given a plane here and drawing a perpendicular from this origin to this plane, and where it touches the plane you have to find out the coordinates of this point P. That is the foot of the perpendicular. Okay, this point P is the foot of the perpendicular. So you are going to find the coordinates of the point P. So to get the coordinates of the point P, we can use this LD, MD and ND, where L, M and N are the direction cosines of the plane and D is the distance from the origin. So we can write this as, here L is 2 by root 29, D is 12 by root 29. So multiplying that to L into D is 24 by 29. Okay, 2 by root 29 into 12 by root 29. Then the next is 3 by root 29 into 12 by root 29. It is 36 by 29. Then N is 4 by root 29 into 12 by root 29, which gives 48 by 29. So you can find the foot of the perpendicular using this formula LD, MD and ND. For this you have to find out the direction cosines first and then multiplying it with the distance from the origin. Is it clear? Okay, so one more question. You have to find the foot of the perpendicular from the origin to the plane. 3y plus 4z minus 6 is equal to 0. So you can write this as R dot, R is xi plus yj plus zk, R dot, sorry, 0i plus 3j plus 4k. Coefficient of x is not here, so we are writing it as 0i plus 3j plus 4k, which is equal to 6. This gives R dot. This is not a unit vector, so we have to divide it with root of 3 square plus 4 square. So you can write this as 0i plus 3j plus 4k divided by 5. Magnitude is 5, which is equal to 6 by 5. So the foot of the perpendicular find out the foot of the perpendicular from this. Zero. Okay, first one is 0 by 5 into 6 by 5, which gives 0 itself. Then y coordinate is 3 by 5 into 6 by 5, which gives 18 by 25. Then 4 by 5 into 6 by 5 gives the z coordinate, which is 24 by 25. So this is the foot of the perpendicular. I hope this is clear to you. Try the questions, subdivisions C and D of question number 4, exercise 11.3. Okay, once again, exercise 11.3, question number 4, subdivisions C and D. Try it yourself. So the remaining topic will continue in the next class. Thank you for joining. And have a nice day.